These are our 3-3 notes on our graphs of tangent, cotangent, secant, and cosecant. I'm going to go through these notes pretty quickly. There are a lot of details here. I want you to know, though, that the main thing I want you to get out of this is how to quickly recognize and draw between 0 and 360 degrees the graphs of the sine, cosine, tangent, cotangent, secant, and cosecant. So there's going to be a lot here, but the main focus is simply the shapes of these graphs. So let's start with what we already know, and to this I want to add two things. We already know that our critical points are our vertices, which are the high points and low points of our graphs. So that would be top of umbrellas, bottom of bowls. Our inflection points are points on the sinusoidal axis where curvature changes. So that would mean where a bowl changes to an umbrella or vice versa. But those are always points on the sinusoidal axis. So let's start with this. You should be able to draw a quick sketch of the graph of the sine and cosine between 0 and 360 degrees. So I'm going to start with y equals the sine of theta. And for me to draw a quick sketch between 0 and 360, I'm going to mark this off for one period, and I'm going to divide that section into 4, so that would be at 90, at 180, and at 270 degrees. My graph of the sine has a range of -1 to 1. It has a y-intercept of 0, and it'll go mid, high, mid, high, mid, low, mid. And that would be what I'm looking for in a quick graph of the sine. If I'm going to do y equals the cosine of theta, then again, I'm going to mark off from 0 to 360 degrees, right, with my important points happening at 90, 180, and 270. Like the sine, cosine has a range of -1 to 1, but its y-intercept is 1, so it goes high, mid, low, mid, high. So you should be able to do that in just a matter of a few seconds. The details we'll add to that, right, are here. These are things we already know. We know that the domain of the sine is -infinity to infinity. The range is from -1 to 1. The period of the sine is 360 degrees. Its critical points, its vertices happen at 90 degrees and again at 270. So at 90 and 270 degrees. Its inflection points happen at 0, 180, and 360 degrees. The domain of our cosine is also -infinity to infinity. The range from -1 to 1. The period 360 degrees. Its critical points are at 0, 180, and 360. And there are, of course, more of these if we continue the curve. But between 0 and 360, that's what we have. And its inflection points happen at 90 and 270. So that's our sine and cosine. Let's look at our cosecant, and then we'll look at our secant. We know that our cosecant is the reciprocal of the sine, so it equals 1 divided by the sine of theta. So we are dividing by values of the sine. What that means is that wherever the sine of theta equals 0, the cosecant is going to be undefined because 1 divided by 0 is undefined. And where the cosecant is undefined, the cosecant will have vertical asymptotes. Whenever the sine of theta is 1, the cosecant will equal 1 because 1 over 1 is 1. And where the sine of theta is -1, the cosecant will equal -1, because 1 over -1 is equal to -1. We know that the secant is 1 over the cosine. So similar thought process here, that where the cosine is 0, the secant will be undefined, and therefore we'll have vertical asymptotes. Where the cosine of theta is 1, the secant is 1, and where the cosine of theta is -1, the secant is -1. So we are going to carefully sketch the graph of the cosecant using only the graph of the sine of theta as a template. So to do that, I'm going to come in here, I'm going to do more than one cycle. So I'm going to come in here and I'm going to go from 0 to 360. Let's go ahead and go another period forward to 720. All right, and let's go back to -360 and -720. We know that we have a domain from 1 to -1 or -1 to 1. And I'm going to do this graph as a dotted line. And I want it to be, we'll pick this green here. So the graph of my sine is going to go right from mid to high to mid to low, back to mid. We're going to repeat that, and then we're going to bring that here, and we'll do another one here. So there's the graph of my sine. Now we know, come here, do this one. We know that where the sine is 0, the cosecant is going to have vertical asymptotes. So the sine of 0 is at 0, so we'll have a vertical asymptote there. At 180, at 360, 180 degrees forward here, right? We've got zeros here. So at every inflection point for the sine, it's reciprocal, the cosecant is going to have vertical asymptotes. The other thing we know is that wherever the sine is 1, the cosecant's going to be 1. So here, 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 and here. And wherever the sine is -1, the cosecant's going to be -1. It's here, here, and here. For all the other values, so if we think about what's going on in this range, our cosecant is a fraction smaller than 1. And when I take 1 and divide it by a fraction, so for example, if I do 1 and I divide it by 1/4, I end up with 1 times 4 over 1, which is 4. So I would actually at 1/4 end up with 4, which is going to be up high. And the smaller my fraction, the bigger my value. So my cosecant graph is almost as though I were taking, right, the section of my sine, anchoring at this point where the y-coordinate is 1 and spinning it over, and I end up with a graph that looks like this. If I do something similar and take the section between here and here, flip it at its vertical asymptotes, anchor it at -1 and flip it over, I get this. And so my cosecant is made up of these separated bowl curves and umbrella curves with vertices where they equal 1 and -1. What happens then is my domain is not unlimited. I have breaks in my domain, and those breaks happen, right, at 0 degrees, at 180 degrees. Oh, sorry, did that wrong. This would be at 0 degrees, at 180 degrees, at 360 degrees, at another 180 there, so that would be at 440 degrees, right, at -180 degrees. And what you'll notice is that all of these are multiples of 180. So we could say that the domain of the cosecant is anything, so all real numbers, given that theta, our angle, does not equal any multiple of 180. So we'll write that as 180 degrees n, where n is an integer. So 1, 2, 3, -1, -2, -3, and so on. And so anything except where it has vertical asymptotes. The range of our cosecant, and our cosecant goes as low as -infinity and continues right up here until it reaches -1, and then it jumps over space until it picks up again at 1 and continues up to positive infinity. The period of the cosecant, this graph repeats itself, right? So we have after 0, we've got this bowl shape and then an umbrella shape, and then it repeats again with another identical bowl and umbrella. So the period of this graph, like the sine, is 360 degrees. Its critical points happen right halfway between where we have a vertical asymptote. So that's going to be at 90 degrees, and then the next one is going to happen another 180 degrees forward from that. So 90 plus any multiple of 180 degrees. It has no inflection points because there is not a single point where the bowl changes to an umbrella or vice versa. Those changes happen across a line, not at a point. Okay? And we can do the same thing with the secant by graphing, right, doing a graph of the cosine. So if I come in here and I do a graph of the cosine, and I'm going to mark this off again at 360, at 720, at -360, and at -720. We know that our cosine has a domain from -1 to 1, and its graph will go high, mid, low, mid, high, and so on. Wanted that to be dashed. Let's see if I can do that. So if I select that, and I want to make that into a dashed line, and then let's select this and make that into a dashed line. That worked out pretty well. So that's the graph of my cosine. Like my sine, my secant is going to have vertical asymptotes wherever the cosine is 0, so it's going to have vertical asymptote here. Another vertical asymptote. Asymptote here, another one here, 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 everywhere the cosine crosses the theta axis. And then our graph will be 1 when the cosine is 1, and then it'll flip over. It will be -1 where the cosine is -1, and it'll flip over. So very similar to the graph of the cosecant, except the asymptotes and the critical points are flipped. So this comes up here, this goes here, here, here. So when we look at this, the domain of our secant, would be all real numbers, given that theta does not equal 90 degrees plus 180 degrees n. The range is -infinity to -1, and then 1 to infinity, just like for cosecant. The period, again, is 360 degrees. Our critical points are at every multiple of 180, and there are no inflection points. It's our cosecant and our secant. Now, I don't have that here, but I think on your notes you have the graph of the sine and cosine. I'm not going to go through that breakdown, but basically what we have going on is this. If I'm going to do the graph of the tangent, we know that the tangent of theta is equal to the sine of theta divided by the cosine of theta. So if we come in and do a little sketch of the cosine of theta, this is -1, this is 1. We know that our cosine of theta looks like this. And since we're dividing by the cosine, then our tangent is going to have vertical asymptotes where that cosine is 0. So we're going to have a vertical asymptote here, and another one here, and here, and here, and here, and here, and here, and here. Right? And that happens at 90 degrees, right? And at 270 degrees, and at -90 degrees, and so on. The tangent is going to equal 1 where the sine and cosine are equal to each other. And that's going to happen halfway through. I'm not going to go through the details of this, but in the end, this is what's happening. Your tangent graph is going to equal 0 whenever the cosine is 0. No, whenever the sine is 0, which would be at 0, at 180, and at 360, and so on. And your tangent graph is going to look like this. What you might notice is that you've got this sort of S-shaped curve that is repeating not every 360 degrees, but actually in a space of what happens in 180 degrees is repeating. So this tangent graph I'm sorry, we're talking about cotangent here. So based on this idea of what makes these equal to 0, your cotangent is going to be undefined, where your sine of theta equals 0 because the sine is in the denominator for cotangent. Cotangent is going to equal 0, where the cosine of theta equals 0 because that's in the numerator. And the cotangent is going to equal 1 and -1, where the sine of theta is either equal to, right, the cosine of theta or its opposite, so plus or minus cosine. So if we're going to do the graph of the cotangent, the graph of our cotangent actually would look like this. So if this is 180, this is 360, if I come back, this is -180. Your cotangent will have vertical asymptotes at 0, at 180, at 360, at -180, and it is a decreasing graph that hits the 0 at 90 and at 270. So it comes here. This is not very good to scale. So domain of our cotangent would be all real numbers, as long as theta does not equal 180. The range is negative infinity to infinity. The period is 180 degrees. It has no critical points because, right, there are no vertices to this, but it does have inflection points at 90 degrees plus 180 degrees n. Final thing we'll deal with is why does the cotangent have a period of 180 instead of 360? Right? And the reason are because the cotangent values in the first and second quadrants are repeated for the same reference angles that happen in the third and fourth quadrants. Respectively. And they do that because all that changes are the signs, and where a positive over a positive gives us a positive, right, which happens in quadrant 1, in quadrant 3, we would have a negative over a negative, which is also positive. That would happen in quadrant 3, right, and similar relationships in the others. So that covers our basics. We'll deal with this a little bit more in class, and we'll really just focus on memorizing the shapes of those so we can recognize them. So I hope that helps. See you tomorrow.